Okay, so we're recording. Just to recap, this is a pendulum. This thing down here is called the bob. We can measure how far we move it based on these numbers up here. These are degrees. The mass of our pendulum was written as 50 grams, and the length from there to the bottom of the pendulum was 62 centimeters. And that catches our recording up to date.
Awesome. So if we have timers ready, I'm going to ask you guys to be my set of eyes on this side. And what we'll do is I'll say, is that 10 degrees? Just about right there. And if you say yes, I'll just let it go. Does that make sense?
So what do I go?
So what we're going to do is I'm going to say ready, set, go. And on go, you'll start your timers and I will let go of the bob. Okay? Do we need one practice? It'll look like this. It'll be ready, set, go. 1, 2, 3. And I got to count till 10, okay? So the first things first, is that 10 degrees?
Yeah.
Okay. Ready, set, go. 4, 7, 8, 9. Stop. What'd you get?
15.32.
15.3, 15.1, 15. Okay. I'll just take the middle one of 15.3.
I'll say I got 4. I got the average.
Oh, Mr. Rose got an average of those three.
15.31.
Should we take the 1 decimal place for our data? So that'd be 15.3. Is that okay? I think that makes good sense for our data today. We're going to do it again. Why do it 3 times?
Make sure it wasn't human error.
Yeah, let's see if there's any human error there. Let's do it again. Katie, am I at 10 degrees?
Yeah.
Okay.
You think we should let one of the students try this, Nabel?
You mean the students get out of their seat and
Yeah.
do this? Mr. Rose,
Toby just got really excited. I have to look. Toby was like, whoa!
Mr. Rose, what about COVID? The kids can't leave their seats.
But you can use that stuff right there, that cloth, to sanitize.
I mean, now we're okay to go?
No, I already go.
You can go first. There's 7 more trials we can do.
There's 82 million tiles you can use.
So, Toby, you are standing directly in the way of everybody to be able to time.
So,
There you go.
Is that going to work? Are we okay?
And also, Toby, see how you are pulling it this way? So, yeah, you want to try and pull it straight back. So let go right now. If you let go, watch what happens.
Nope.
See, so when you pull it back, you need to make sure to try and pull it back straight, like so. And we're only pulling to 10 degrees. Is that 10 degrees? Is that 10 degrees? All right, so we want to pull for the string to be right there. And a little
Timer's ready when you get
there.
it.
Yep.
Okay, timer's ready.
Oh, my timer's on the ground there, Brogan.
God.
Toby, it's not 10.
That is, yeah, that's way farther than 10. That is like
Yeah,
8.
like right.
Right to there, and then you're going to let it go. Did anyone hear you? No, this won't count because the timers weren't ready. So we're going to say it again. I'll help you. If you want me to say ready, set, go? Okay. Maybe a little bit more right there. Ready, set, go. Nope. Reset. You were holding like this. Can you hold your hand on the outside so you just open your hand? See how you're holding it this way? Can you hold your hand on the outside of it? Can you switch hands? There you go. That way now if you just let it go. Ready, set, go. Nope. You can. You'll get it. Just watch. I'm going to hold it and just let it go, not give it any push. Ready, set, go. No, you gave it a big push.
I didn't give it.
I saw your hand kind of do that. You just want to try to concentrate. Open.
I have an idea.
I like it.
I have an idea. Toby, take the book.
Good.
Hold the book. All right. Let go of the pencil for a second. So what you're going to do is this. And Mr. Nabel is set your mark, get set, go, and you're gonna let the book go. Did you hold the book? There you go.
Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop. What did we get?
15.33.
Whoa.
Other people?
Any other timers?
You only got 2 that time?
15.33.
15.2, okay. That's a time of 15.25, Mr. Nabel.
All right.
I don't know.
Who else wanted to come up?
We're gonna let other people try, don't we? Thank you.
Anyone else going to come up? Yes?
I got lazy from just the
You
channel.
got lazy.
Would it be easier if I went
Go ahead, Matt.
back there?
Doesn't matter. Either way, whatever you think
Can I
is
go
best.
after?
Sean, sorry. Go ahead. Yeah.
Can I go after?
Yep.
Confused.
Yeah, I was confused too, clearly. So, Sean, if you could step to your left or your right.
Yep.
Perfect. And that actually even looks like it's 10 degrees from my camera.
Ready, set, go. 1,
1,
4, 5, 6, 7, 8, 9.
10.
Stop.
Oh,
Nice.
no, I didn't
Times, what do we got?
stop the storm. I just restarted it.
It's fine.
Times.
Anyone got times?
No.
Matt?
I still have to keep my mind on.
You're a machine.
You're a rule.
Well, as we now have 1 person participating, the average I got there was 15.1.
All right. Now,
Maybe I shouldn't have
nice
done
job.
it.
Thank
I was
you.
also doing
No,
it.
no, it's good. It's fine. We need an average of all 3 trials. How do we do that?
Did you add them all up?
Add them all up, and I got
And then divide by
45.65. What do I do
Just
now?
put on your head. Don't you divide?
Divide by 3 because there's 3 data points. What do you get?
So one of you got the AirPods.
If you are sitting in this class waiting for other people to put numbers out and answer the question for you, you're not getting the practice. And if you can't do this on your own right away, it's a good time to be working through the data and practicing data collection. What's my average?
We dividing all 3?
Yep.
Adding them
You
all.
add them all up and then divide by 3 to get a number that represents all 3 data points.
Okay.
Do you want to share? You say 15 point what? 2. Okay.
Oh, I think I did it.
Does everyone get the same 15.2 as an average?
Nope.
So that is the amount of time on average it takes to do 10 periods, 10 cycles of harmonic motion. What is the time for 1 period? I'll repeat my question. 15.2 is the time it takes to complete 10 periods or cycles of repeating motion. What is the time of 1 period? Yes, Toby, what do you think?
1.52.
Yes, if I take this number and divide it by 10, I get 1.52. So, the period of harmonic motion from 10 degrees is 1.52 seconds. Period is the first vocab word we are trying to stress in harmonic motion. Does anyone hear what I said? Did you catch a definition yet for what the period of a harmonic motion would be? What does that mean?
Time it takes for it to be completed.
The time it takes to complete 1 cycle. Because after 1.52 seconds, it then starts to repeat and go to the second cycle. So our definition for period is the time it takes to complete 1 cycle of motion. Time it takes to complete one cycle of motion. Now with the pendulum, there's different things we could do. We could make the string shorter. We can hang more weight from it. Or we could maybe give it a bigger amplitude. Instead of 10 degrees from equilibrium, we can go 20 degrees from equilibrium. Would anyone like to try that? Anyone want to come up out of their seat and do it again?
Matt does, because he's using my pencil.
Hey, you want to come up? All you got to do is bring this up to 20 degrees and let it go.
Oh, Katie wanted to go. Forgot.
Katie wanted to go too.
Matt, this is the charge for my pencil, man. Sorry, I didn't tell you ahead of time.
Okay, Katie, you can practice if you want. You just go to 20, the best you can, and let it go. Ready, set. Wait, I'm sorry, timers weren't ready. Hold on.
And it looks pretty good on my end.
Timers, ready, set.
Wait.
No, hold up, Katie.
Wait, what?
I'm ready.
You okay, Toby?
Yeah.
Timers, ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop.
15.9.
15.78.
15.89.
15.8.
You guys, the last trial we did at 10 degrees was 15. You're all telling me that it was 15 again?
15.8.
Well, that's why we do it a couple
15.9.
times, right?
Okay. Sean says
I got an average of 15.76 with the 4 people that said something.
15.7.
7.6. We're only taking one number after the decimal, so what do I do?
15.8.
And round it up to 15.8. Okay. Now that seems a little higher. Do
Yeah,
we need to do it again?
I agree.
Do we need to do it again?
Yep.
Who wants to do it? Matt, come on, go ahead.
He's like, son of a
Gotta pay
dogfish.
that toll.
We knew a dogfish was a real thing.
Yeah, if you can.
And if you can, stand to your left or right, because we can't see.
Timers. On your mark. Get set. Go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop.
15.30.
15.46.
I accidentally messed up, so I couldn't get it time.
That's real life. Matt, what'd you get in timer? I know.
So between me and Toby, we got 15.26.
And me,
Oh, sorry, I missed Sean. Sean, what did you get?
15.46.
I had 15.46. Toby, did you have one?
15.3.
Oh, I missed Toby. Sorry. 15.46 plus I had 15.06, and you had 15 point what? 34?
Yeah.
34 divided by 3, 15.28.
That tells me to round out to 15.3. Okay?
Yes.
Can I say something very randomly that I'm just thinking about? I mentioned this to one of my classes. I should mention it to every class. We haven't had a fire drill all year. I'm expecting at some point to have a fire drill. And I want to remind you to know the building as freshmen, if you haven't been in the building all year, to know where your exits
No, not
are.
there.
No, not that I know of. I wasn't saying this other than just thinking about it for a moment.
You don't know what fire drills are.
My point is that from this room, we exit out the staircase right next to us, and we go out a door that's right below us next to the Watertown Access Television Station. So just so you know, it's right below us. You should know the building well enough to know how you'd get out in any room.
I've been here ever since summer.
Wait a second, I haven't touched this. What's going on here?
No idea.
Matt, when you were here, what is this, like 5 degrees from zero? When you were here a moment ago, didn't you hold it up to like 20?
Yeah.
Why isn't that 20 anymore?
Momentum is slow.
It's not the same as it was, though. Something's changed. We'll get there. We'll talk about it. One more data point. Is that 20?
A little higher.
Yeah, I did.
Perfect.
Timers. Ready? Timers.
Oh my god.
Timers.
I'm
Ready.
ready.
Set. Go. 1. Nine. Stop.
How?
15.55.
15.95.
4 plus. I got Toby. What'd you get, Sean?
15.55.
We get an average of.
Oops.
I got 15.95.
Mine probably around 100%.
I got an average of 15.35, including mine.
I'll round that up to 15.4, and I need a class average for those 3 data collections.
Oh,
So now we're adding it all up again?
Wait a second, Mr. Nabel.
Yes.
So, if I look at, and this is a question for everybody here. If I look at those data points, 15.8, 15.3, 15.4, are all of those seem like good data points?
Yes.
Look at the ones above. We have 15.3, 15.25, 15.1. They're all kind of close together. Then number 2, we have 15.8, 15.3, 15.4. Do one of them seem like it doesn't fit
15.8.
the
Why do you say that?
15.8?
Why?
There's such a large leap between them.
Okay, so in a lab report, you might be able to write about that and say, one of my data points seems like an outlier. Maybe it's a little bit away from what I expect.
Yeah, just wanted to point that out, and that's also like when we do averages and stuff. We should know, looking at those numbers, that my average, the answer is going to be somewhere between 15.3 and 15.8. So when you do it, if you get something that's outside of that, you probably made a mistake. You want to try and do it again.
Anyone get an answer yet for an
Yes.
average?
1.5.
15.4.
So that's how long it takes.
1.5.
15 point.
No. I think I'll just count for 1.
Gotcha. So for one swing, we're saying divide that by 10. And we get,
1.55.
After 1 swing,
good.
I didn't divide it by 20.
No,
Guys, didn't matter.
10 swings, right? This is the average.
Sorry, which question?
Some people were still writing, so I held off on finishing my thought, but I'll say it again. Did it matter whether the pendulum swung from 10 degrees away from equilibrium or 20 degrees from equilibrium?
No, it's a negligible difference.
Do you think it's going to matter if it's 30 degrees from equilibrium?
Maybe.
Let's do it once.
By a lot.
Timer's ready. Yeah, man. In 1 second, you got one more trial. Or I should say in
Hold on.
15.1 seconds. Is that 30 degrees?
Yes.
Timers, you ready? Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop. Don't even tell me. It's like 15.3.
15.95.
15.8.
15.6.
15.8 is what I got.
All right, I got
Yeah.
15.2, 15.8, 15.6. What else? Somebody else get? Sorry, I got a 0.8, a point.
15.8.
I got that one.
Okay.
Sean, what'd you get?
15.9.
What is wrong with all of your timers?
I'm just slow.
Average 15.62.
Okay. That tells me if I were to do it one time, I've got a period of 1.56 seconds. Are there major differences between 10, 20, and 30 degree from equilibrium?
Nope.
No. Now we can do 2 more trials, but for the sake of time, I think we should just accept that that data is relatively showing no change. Yeah. Now, Again, we're not doing a full pendulum lab. You can't use the bathroom, right? We're not doing a full pendulum lab, but there are 9 more trials we could do where you could put on different masses and try it, or change the string length and try it. You want to see one thing? Here's a shorter string. What do you think is going to happen to the period of the pendulum?
Takes less time.
You want to do 10 trials?
Yeah.
Ready?
10 trials?
10, 10 cycles, 10 periods. Ready? Timers, you ready?
Reset. Ready.
Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop.
11.8.
I got something different.
I got 11.86.
I got 12:22.
Okay, still 11 or 12 seconds. Is that slower? Excuse me, is that faster than 15 seconds?
Yeah.
Okay. So there are different ways to affect the pendulum. Mainly, here we go. You just saw the length
and
of the
weight.
string.
Wouldn't the weight make it like
So, firstly, you physics people, we don't use the word weight.
Mass.
We use the word mass, and those are different.
I got there's something.
Ah, there is not.
Are you sure?
I am
Yeah,
positive.
but every physics
Here you go, guys. Ready?
Maybe there's something
Instead
going
of
on
50 grams, here is 150 grams. Are you ready?
I have a theory it's gonna go faster.
Wait, hold on. What was the second one?
Before you do that,
That's my hypothesis.
She's gonna have a better way to do it. She's gotta.
What's the second one?
The second one.
this is going to be loud, so I'm sorry.
Ready?
That's a big book, right?
Yeah.
The single sheet of paper, right? What's the difference between them?
Size.
This is a little ball. This is way more massive, or as Toby would say, heavier. If I drop them both
On the table. Not on the orange part.
so you can see them,
That scared me.
What hit first?
Well,
they hit the ground at about the same time.
Yeah.
What pulled those down?
Gravity.
What makes the pendulum swing?
Gravity.
gravity.
So now, if Mr. Nabel adds mass to the pendulum, do you think it's going to go faster, slower, or stay the same speed, or have the same period?
Same.
Why?
Nice.
What's the thing that makes the pendulum pendulum?
Gravity.
Gravity.
Pendulum.
Ready? Timers.
Log me in. Hold on. Stop.
It would be faster if you weren't texting.
Ready?
Mr.
Set.
Nabel. Wait, hold on.
Yes.
What's the second one?
The second one, what?
Second.
I don't know what you're asking, sorry.
How come you didn't fill in the chart? We're skipping those two,
Yeah,
Joe.
we didn't do those. Because we're pointing out that the data really doesn't change. So I don't need more
You
trials.
can put an X through those two trials if you like.
Ready? Set. Oh, I didn't say go. Sorry. Ready? Set. Go. 1. 2 periods. 3 periods. 4. 5. 6. 7. 8. 9. Stop. Don't tell me 15.3.
Yep.
15.7.
Did the mass change?
I got
Did the mass
15.6.
affect the period?
I got
No.
15.9.
So I know I said we're not doing a full pendulum lab, but I just proved to you the mass doesn't change the period of one cycle of harmonic motion. The string length does. Don't worry about, we're not focusing too much on pendulums, but we do want to focus on some of the key concepts that a pendulum allows you to observe. This is harmonic motion, something that will continue and repeat itself. I start here, I drop it, and it returns to its starting position. The moment after it returns, it starts another cycle and repeats and repeats and repeats. And this is what we call harmonic motion. Now, there are 3 key vocab concepts that we need to understand about harmonic motion. The first one was period, the amount of time it takes for one cycle. What did we say was the period of this pendulum? What is the period of this pendulum?
You're asking for the definition of the word period?
No, I'm looking for the actual number, the value that we calculated. What is the period of this pendulum? Not 15.2, because that's 10 cycles.
Oh.
Period refers to one cycle.
That's 1.5.
1.52. So the whole cycle takes 1.52 seconds. So does it complete a whole cycle in 1 second?
No.
No. If I were to stop it at 1 second, it'd be about there. It didn't get all the way back. It's somewhere about there. So there's another concept with harmonic motion we have to understand, and that is the idea of frequency. Frequency is the number of cycles that occur in 1 second of time. So this pendulum might have a frequency less than 1. It might be something like 0.75. But it's a little bit different. Period is the amount of time it takes to do one full cycle, and frequency is the number of cycles that occur in 1 second. So let's write that down as another important definition. The number of cycles that happen in 1 second.
And there are easy ways to remember that. The easiest way I know is if I think about the President of the United States.
Joseph Biden.
If I ran for president, or Joe Biden, who was the president, when was Joe Biden elected? What year?
This year. 21?
2021 is when he started? Or you can go 2020 because it's easier.
Yeah.
What is the next time we vote for president? How many years later?
2024.
2020, how many years is that?
4.
That is the period Joe Biden will be president. It is the time for one whole presidency. How frequent are you supposed to vote? One vote every how many years?
Every 4.
Every 4. The opposite. That's the frequency. It is the time that you put your cell phone away if you're texting before I take it for the rest of the day. It is the times that you do something in a given amount of time period. How often it happens, the number of cycles, and in physics we'll use 1 second. That's why in physics it's cycles per second. The presidency would be cycles per year. I vote once per year.
Now, I'll add one note to this. Period is the time it takes to complete one cycle. That's going to be in seconds. We have a new unit here that you haven't heard yet this year. Frequency is the number of cycles that occur in 1 second, and that's measured in something called hertz. If you want to add that, you can say measured in hertz. Maybe the first time you're seeing that. And our final vocab word is amplitude. Anyone catch from our description today what amplitude is all about? Look at the data table. We looked at the angle of the pendulum. I could have taken that in centimeters, I told you. That's another way to look at the same idea. But when this thing is held at 30 degrees, you know, it's like 20 centimeters from equilibrium. There's different ways to measure, but in general, what's the idea of amplitude? What is that looking at?
What does it mean if I get all amped up?
Get more energy?
I get angry, I get more energy. Would you say I get bigger?
Maybe. I don't know.
Like, well, you said I get more energy. Does my energy get bigger?
Yes.
So what do you think amplitude means?
Increasing something?
How, well, increasing is a good example of it. But I could have a small amplitude. What if I'm not amped up? Would that be a small amplitude?
No.
All right, my example fell flat, Mr. Nabel. Sorry.
Okay, no, we're trying to think about being amped up. It's the same word. When we look at waves, though, you're not going to be able to look like how much caffeine Mr. Rose had and how amped up he is. It'll be measured in different ways. So there's not just one unit, but it's the maximum distance from equilibrium. Now, that might not help if you don't know what equilibrium is.
But what I did like what Sean said is it reflects the energy. like I would say if I was gonna say energy and amplitude were kind of the same, I'd say the amplitude of our class is like way. I mean, like I can step over it.
Because it's Monday morning, you think?
I mean, it's like 10 after 10.
Daniel, what were you gonna say? Not yet. Someone's out. Let's look at amplitude in one more example. How would you describe the amplitude of this right now? It's still moving.
It's very low.
Very low. Why is it low?
There's no force.
Okay, I'm gonna drop it right now.
I guess that's one number.
What's the amplitude? Well, it's, you know,
Definitely
maybe I started at 20 degrees. Is it still that big?
Yeah.
What's gonna happen in 30 seconds?
It'll slow down.
It will slow down. Why? Is gravity still acting on the pendulum?
Yes.
So why would it slow down?
Because it's both numbers.
Nothing Sean said is wrong. I'm just looking for other people to
Oh,
chime in
okay.
and think. Yeah, what do you think? It lost a little momentum. And I guess the next question though is why? Where did it go? What is
The momentum goes in completing each cycle.
the momentum goes in completing each cycle? Then where did it go? I don't see any momentum. Why would this slow down?
When it completes the cycle, it's slowing down because for it to complete it at its highest point, it's losing momentum.
Okay, it's losing momentum. I'm going to keep asking the same question until someone kind of gets at the why, though. Why would it lose any momentum?
Because that
You have a mask on. You can't affect this. Why would this lose any momentum? What could possibly explain this?
Definitely thought that would help.
gravity.
Gravity? What else?
What was I pretending to do with the pendulum?
Low.
Robert, what you got?
Oh, it must be friction.
Yeah, friction. What
Air
is,
high five.
what is this pendulum fighting through right now?
Gravity. With force. Well, it's not
Air
much.
resistance, air molecules get in the way. You can picture this thing having to fight through. I know we can't see air, but there's air molecules all over the place, and this thing has to fight through the air. And when it does that, some of its energy is transferred or lost, we keep saying. Okay, so this idea that over time, objects like oscillators with harmonic motion might slow down. There's a concept that I'm introducing here, and it's in italics if you want to circle it on your paper. The idea of damping is what we just described. And I want to know, how long do you think it takes until damping is visible on this oscillator? Would you guys like to time it one more time?
Yeah, how long?
I'm asking you to tell me how long it takes for damping to occur. Damping is the gradual loss of an oscillator's motion. Here it's due to friction. I agree with what you said. There's air friction slowing it down. It's not like gravity changes. Gravity is always the same force acting on it. So I'll start. Ready, set, go.
Oh.
You tell me when you think you see damping occur.
I think there's some confusion.
Why?
Maybe. Okay, I think now.
No, it's reaching the same spot every time.
You think it's reaching the same spot still?
And now it's slowing down. Yeah.
Damping is when an oscillator loses its motion. So I will start this one more time right there. What number is that? Anyone got a number?
Looks like 30.
30? Is it still at 30?
Yeah.
Okay, so tell me if you think it gets less than 30. Probably not now. There's only a few seconds. Okay.
And
That is not getting much above 20 already. So 10 seconds in, we already could observe
Okay,
damping.
now I know this damping.
Yeah. So you can write down whatever you want for this one. The idea being it didn't take very long. It was like 10 seconds, but I want to point out that an oscillator, something that's repeating its motion, you might see its motion dampen or slow down due to friction. That's the introduction to that vocab word, which we will use throughout the next chapter. I'll give you a few seconds to finish that thought.
6 minutes in class.
We'll finish with a couple calculations, but I just want to point out here, this packet is 6 pages long and it looks like a lot, but what I really did is I gave you textbook reading because I know we don't often assign a lot of textbook reading. And here it is. From page 414 to 418, here's the most important concept. I give you reading to look at it. Defines harmonic motion. Defines the word cycle, repeating motion. Says here that anything that repeats itself is called an oscillator, a word we use often. And then it gets into some of the vocab we've stressed today, like the word period and frequency. And then it gives you a little bit of support for calculating those things. I'd like you to find yourself on the bottom of page 3. If you want to add any note, you can. Anything I write on the board that you think is helpful, you can write down. I want to point out, how do we measure period? What did we say in the first page? How do we measure period?
Time it takes the time. Wait, one cycle.
Time. The time it takes. Time in seconds. Time. I stress this because period is abbreviated with a capital T. A little tricky, but it's on your MCAS formula worksheet. You never have to memorize that. It says capital T equals period. Great. T is equal to 1 over frequency. Let's look at the formula for frequency. Frequency is equal to 1 over the period. They're reciprocals of each other. They're opposites. T equals 1 over F. Well, F equals 1 over T. Let's see if we can use that. T is measured in seconds. What is F measured in?
Frequency.
F stands for frequency measured in hertz. So let's give an example.
And if you forget, look what they have written here. F equals 1. It says period in seconds. So you could literally just write 1 divided by seconds for an answer. Like a number, I don't know, 0.5. 1 divided by seconds, because I forgot, so it's okay.
I have a question.
Yeah.
Is the 1 always going to be there?
Yeah. That's the formula. 1 divided by, well, let's use it and let's practice before class ends in 4 minutes. You ready? A pendulum with a string length of 70 centimeters holds a mass of 0.5 kilograms. The pendulum completes 10 cycles in 18.34 seconds. What is the period of the harmonic motion created by this pendulum? I go back and I say, what is the period of this pendulum? I look and I see my definition of pendulum as the time for 1 cycle. So what information am I given? The period is the time it takes to complete 1 cycle. In this example, in the pendulum, it says 10 cycles took 18.34 seconds. So what would 1 cycle have taken?
Almost like we just did this.
This is what we did today in class. Joey, if 10 cycles takes 18.34 seconds, what would 1 cycle have taken?
10.
Okay, I got the answer.
with a unit?
1.86.
Okay, so we said if 10 cycles took that long, one cycle would take 1.834 seconds. No fancy math, just what we did in our lab work today, guys. It's a little worrisome that we did that 3, 6, 7, 9 times, and no one right there is jumping out of their seats with that answer.
I was just a little sorry.
No, don't be sorry. It's okay. I was just pointing out that that was no trickery there. That's kind of what we did today in the class.
I got it. I got the same answer on my phone.
So for the F, F, is that always going to be F?
Our second question gets into a frequency sample. You want to try that?
Yeah.
The bell rings in 45 seconds.
Period is the amount of time it takes to complete one cycle. Frequency is the number of cycles that happen in 1 second. So what is the frequency of the oscillation in the pendulum example above?
So
Frequency equals 1 over the period. 1 divided by, what's the period? What's 1 divided by 1.834?
1 divided by 1 is
1 divided by 1.8.
Oh.
What did you get?
calculator to the rescue. 0.54525627.
8.54 hertz.
A lot of numbers.
You guys, it's going to be June at some point. The year is going to end, and you will have successfully sat an entire year letting other people do calculations for you. I don't understand. You can sit there without a calculator open. Come to class with a calculator tomorrow.
I have a calculator.
You have to have it open and ready to go.
I
You
have
can't
a
just sit there and let
calculator.
other people do the calculations.
I have a calculator. I do calculations.
Do you want to control P print this, or we can put it on our notebook when you're doing it?
Yeah,
Yeah.
I just spent
Because we didn't do it for E-block, but they
There's
should
no
post
answer
it.
on it, but-
Yeah, but no, you typed answers in today. Just not those last two.
You'll wait until I'm ready. It's okay. Just wait 1 second.
Yeah, but finish good. Don't be late. Yeah, but finish.
Deep.
It's okay if not.
Nice job.
So I'm not,
Great. I thought you
for
did
class
great.
right now, that's
Yeah,
fine.
very good.
I'm not 100% sure what's going to happen with the MCAT, but I'm going to find that out tomorrow.
Yeah, I'll look into getting a calculator. I'm just saying.
Yeah, that's totally fine. Okay.
Thank you.
All right, tomorrow's math, right? Or is math?
I don't know.
All right. I would have been good if I opened up those files, yeah, to see.
You're right. I checked all that.
Did you print?
Yeah.
All right, so
Bye. Have a great morning.
my birthday's tomorrow.
Is it really? Happy birthday coming up. What do you think you guys will do?
Stuff.
What stuff are you hoping to do?